Hey guys, welcome to lecture 42, group by on data frames. So in this lecture, we'll be learning how to use group by on data frames. So import the usual, NumPy is NP, Pandas is PD, and then from Pandas import data frame and series. So we're going to start out by making a data frame. So we'll say dframe equals data frame. And I'm going to construct this data frame using a dictionary. So let's go ahead and start off with the first column, K1. Then I'm going to just have this column be a list of letters. So we'll say X, X, Y, Y, and finally we'll have it be Z. Okay. Next column will be K2, second key, and this one I'm just going to have it be a series of alpha and betas. So alpha, beta, alpha, beta, and then alpha finally. And then we'll have two data sets that will just be random numbers. So I'll say dataset 1, I'll call this guy np.random. .randn, have it be 5 numbers, and then we'll have dataset 2, and we'll just have this be np.random.randn, have it be 5 as well. Okay, and then let's just take a quick look at what that data frame looks like. So we have a series of 5 by 2 random numbers, that matrix there. And we have our two data sets and essentially two keys for those data sets, the K1 and K2 columns. So how can we use group by? Well, we can use group by to create what's called a series group by object. So I'm going to say, let me grab the data set from the dataset 1 column and group it by the K1 key. So I can say group 1 equals from the dataset column, the dataset 1 column, I'm going to say group by, and then I'm going to group it by the K1 column. And then if we want to see what this looks like, we actually are just going to get a confirmation it's a series group by object. We won't actually see what it is. So there's the kind of object it is. If we want to see stuff, we can perform operations on the particular group. So I can say group 1 and then check out the mean. And now I have K1, the key, and X, Y, and Z, the means for each of the dataset 1. So I can use group keys that are series as well. So to expand on this example, let's go ahead and make some arrays to use as keys. So I'm going to say cities equals np.array, and now I'm going to put in some city initials. So I'll say NY, let's put in LA, put in LA again, and then I'll have 2 more New Yorks, NY. Okay. Those are my cities, and then I'm going to have some in the month array as well. So I'll call NumPy array, and then we're going to make a list of just months. So Jan, February, January. I'll just have it be alternating. January. Okay. So let's run that. And now using the data from dataset 1, I'm going to group the means by city and month. So to show you what I mean, let's go ahead and try that out. So let's grab dataset 1 column, then we call group by, and what do I want to group by? I want to group by cities and month, those two arrays. And then I want to grab the mean by that. So what does that look like? So it's lined up the cities first and then the month, so it's grouped them in that fashion, and then it's averaged out the dataset 1 based on those two arrays that I assigned to it onto dataset 1. Let's see the original dataset again, so I'll call dFrame. So here's the dFrame, and I can see the values that line up. So I have my 0.899, that was LA February, 0.533, that was the January for that guy, and then the 252 was New York February. Alright, cool. So those values lined up. We can also pass column names as group keys. So let's go ahead and try that out. So for instance, I can say dFrame dot group by K1 and then get the mean from that. So now I've grouped my data frame by this K1 column. So I grouped up all the X's, all the Y's, and all the Z's together, and then I grabbed the means of those two data sets based on their K1 key. So for instance, if we look at dataset 1 on the X row, that result is just the average of negative 0.3 and 0.89, since those two were assigned the X on the K1 column. Okay, and then we can even say something like group by method to get the group sizes. So I can say group by. Well, before we do that, I can just show you real quick that I can get the mean on multiple columns. So I can say group by, let's say we just did the mean on K1. If we wanted to do the mean on both keys, I could just pass a list and then ask for the mean. And now it's giving you the average based on both keys. So the average for every term in the data sets that had both X and alpha, or X and beta, or Y and alpha and Y and beta, or just Z and alpha out of those two data sets. So hopefully these examples are starting to get a little more concrete as we call by certain keys and get the means. And now back to getting sizes, I can say dFrame dot group by. I'll group it by the K1 key and then get the size. So this means I have two terms as X that have X and K1, two terms that have Y and K1, and then one term that has Z and K1 in that data frame. And if I look at that data frame, I can see that was the case. Cool. So we can iterate over groups as well. So to show you an example of this, I will say for name and group in dFrame dot group by, we'll say it's K1. I'm going to print, this is the group name, so I'll say this is the parentheses S to get that string. This is the group, label it name. I'm going to print group and then print a new line. So what this is going to do is it's going to print out, it's going to check the name and check the group, and it's going to print out this is the blank group from key 1. So it should say this is the, since K1 is X's, Y's, and Z's, so it's going to iterate through all those names. So it's going to say at first this is the X group, and then it's going to give us this data set here, since that was the X group. Then it's going to say this is the Y group, and it should give us this data set here, since those both have Y as their K1 value. And then it's finally going to give us the Z group. So let's go ahead and see if that worked. So that's what we get. We say this is the X group, and it gives us the data sets and the 2 columns for that group, and again for the Y and the Z group. So that was iterating by a single key. We can do the exact same thing for multiple keys. So I can say, for instance, for K1, K2, group in D frame dot group by, and I'll say K1, K2, and I can print, I can say key1 equals the string, which we'll see in a second, key2 equals the other string, close that off, and then we'll call K1 and K2 to fill out those keys. I'll say print the group, and then print a new line to get some separation. So let's think about what this is going to do. What this should do is it should print out both keys for you. So right now our keys that we're using are K1 key and K2 key. So key 1 is going to be your letters, so your X's, your Y's, your Z's. Key 2, since it's K2, it's going to be your alpha or your beta. Then it's going to print the group that belongs to both of those keys. So for instance, the first thing we should see, and I will print the D frame so we have a reference. For the first iteration, I should get the first key, which is K1. So it's going to say key 1 is equal to X, and then it's going to say key 2 from K2 is equal to alpha, and then it's going to print the data set where that's true. And for this, it just happens to be one row, so it should be printing out that data set. And then it's going to do that for the rest of them. So let's go ahead and see if that works. And there you have it. You have key 1 equals X, and then key 2, I forgot to write equals, so let's run it again. Okay, now we've added an equals there. Equals alpha, and it's giving you the data set where those keys matched up. Alright, and it's done that. It's iterated that through the entire data frame. And you can see that data frame there. Great. So, what else can we do? So a possibly useful tactic for this is creating a dictionary of the data pieces. So if we wanted to do that, I could say something like, have an object, group dict, and I will create a dictionary by using dict, and I will pass a list through it, and that list is going to come from dframe group by, and I will group it by the first key, that K1. So let me run that. So now I have my group dictionary. And so now let's show the group with X. So we can say group dic, and we'll pass it with X. And now it's shown us every row that had X as K1 value. We could have also chosen to do this with access equals 1. So let's create a dictionary for D types of objects. And that's D types as in the letter D. So I'm going to say, make another object, group dict, and I'm going to label it also access 1. I'm going to do the exact same thing, dictionary list, and then I'm going to do this by creating dframe group by dframe.dtypes, and I'm going to do this on access equal to 1. So let's run that, and then let me show you what that looks like. So what did we end up getting? We ended up getting basically a separation of your types. So here you have the D types, which are just your floating numbers, and then you have your letter types, which were the K1 and K2 columns. So it's actually separated the data frame by the types of data, and it did it along the axis equal to 1. Alright, great. So we can use group by to actually separate data by the actual data type. So if you wanted to separate numbers versus words or something of that manner. Next, we can learn how to use group by with columns. So let's go ahead and make an object called dataset to group. And for this example, let's say if we only wanted to group the dataset to column with both set of keys, I can say dframe.groupBy. I'll pass a list of both keys to it. And then say it's equal to dataset2 right here. And then we can get the mean of this. So dataset2 underscore group.mean. So this is going to find the mean of dataset2 using both keys. So it's going to look at all the dataset2 values, then group it by both keys, anything that has x's and alphas, x's and betas, y's and alphas, y's and betas, z's and alphas, and then it's going to average up all the objects that share that. So if we look at that, that's the result we get, and since there's only one of each object, the average is going to be the same as that data itself. So it's grouped it, averaged it, but since they all only had one entry for that both keys, it's the same as the value. So we have, for instance, negative 0.19, negative 0.19 here, and it's x is an alpha, x is an alpha. So that's about it as far as group by. We'll be using this tool slightly in the future. So go ahead and then look back at the examples. The main takeaways is that you can group by, and you can either group by columns or group by your certain keys, and you can get certain information off your data frame and leave other things behind. Alright, so next we're going to have a quick lesson on grouping with dictionaries and series. I'll see you there. Hey guys, welcome to lecture 43. This lecture we'll be going over group by in a little more detail and how to use it on a dictionary and on a series. Alright, so we're going to import the usual. You can either copy and paste this or just type it out. NumPy as NP, Pandas NP, and then from Pandas import series and data frame. Okay, and wait for a second for that to import, and it's done. Alright, awesome. So let's learn how to use a dictionary series with group by. So, first thing I'm going to do is make a data frame. Let's call this data frame animals. There's my data frame. It's going to be just some random numbers. So let's just make it, well, actually let's make it some a range of numbers. Let's say NP arrange. We'll have 16 numbers, and we're going to reshape this into a 4x4 matrix. So those will be our values. Our columns, we're just going to have letter columns, so we'll say W, X, Y, and Z. And then our index will just be some animals. So we'll say a dog, we'll have a cat index, we'll say bird, and then mouse. Okay, so that's our data frame. Let's check it out. Animals. Alright, now I'm going to add some null values to this. So to do that, I'm going to say animals dot ix. So let's say through 1 and 2 on the W and y columns, I'm going to say those values, set them equal to null. Okay. Let's do that, and now let's see animals. So what we should expect is on cat, yep, here we go, that w and y are null. Okay, and you can choose whatever null values you want to replace with null. So let's say I had a dictionary with behavior values in it. How could I use that? So let's make a dictionary and call it behavior map. And we're going to be creating a dictionary for this. So I'm going to say W, let's set that to good. Let's set X to bad behavior. We'll set Y to be good as well. And we'll set Z to be bad. Alright, so now we have our behavior map dictionary relating each of the columns to either a good or a bad behavior. And now we can say animal underscore col. Let's make another object. So we'll make a group by object and say that's going to be equal to animals. And we're going to group that data frame using that behavior map. And we're going to schedule it along axis equal to 1. And then let's say animal column, let's get the sum. So show the sum according to the group by using that mapping we just did. Okay, so what do we have here? We have dog, cat, bird, and mouse, and now we have a bad and a good column. So what this was is it summed up all the values that were good and bad for each of the index rows. So for instance, let's take a look at bad dog and good dog. So bad dog, well, for good dog, we have 2 there. So that should have been equal to the good values, and the good values were W and Y. So let's look at W and Y for dog. So W for dog was 0, and Y for dog was 2. So if you sum up the quote-unquote good values on that behavior map for the dog, you'll get 2, 0 plus 2. And then for bad, the X and the Z, you'll get 1 plus 3, which is 4. And it did that for all the index, for dog, cat, bird, and mouse. Cat being null, since there was no good cats. And I may have done that on purpose, since I don't like cats. Anyways, let's try it with a series now. So, we'll make a behave series, and we're going to make a series out of behavior map, and then let's go ahead and show that behave series, or behave, I guess, since I forgot the E. So now we have our map. The W was good, X was bad, Y is good, Z is bad. So that's our series out of that dictionary. And now let's group by the series. So let's take our data frame, animals, and we're going to say group by that series, and again do it along axis equal to 1. And now let's count. So now we're going to count the total of bad and good instances for each animal based on that series. So now we get 2 and 2 for dog, since it's just doing a counting, not a summing of them. So let's show our D frame again. Nope, sorry, our data frame is called animals. There we go. Okay, excellent. So, what does that mean? That means the dog had 2 instances on the bad columns and 2 instances on the good columns since it was counting. Let's assume that we wanted to group by the length of the animal names. So we can just pass the length function into group by. So this is going to be a really interesting thing we can do with group by. So look at the animals, look at the length as far as characters of each index. So dog and cat are 3 letters long, bird is 4 letters long, and mouse is 5 letters long. So we can say animals group by, and that's going to take the length of each index, and then we can get the sum. Alright, so now our index is the number of letters in the animal name, and then it's summed up, those guys. So for instance, if we look at index that's 3, that summed up the column values for the 3-letter animal names, dog and cat. So let's look at dog X was 1, cat X was 5, and now since we grouped it by the length of the animal name, 5 plus 1 on that X column equals 6. And it's done that for each of the column values, and bird and mouse as well, since they were 4 letters long and 5 letters long respectively. We can also mix functions with arrays, dictionaries, and series for group by methods. So let's check that out. We can say get a set of keys. So I'm going to make a list for this. I'm going to say A, B, A, B. So I have my keys. And now I'm going to group by length of name and the keys to show the max values. So I'll say animals dot group by, and then I'll group by the length and those keys, and I'm going to find the max values for each of those. So what has it done here? It's set that key list onto that previous data frame we had. It's pushed it onto it. So now that index of 3 now has a sub-index of A and B, and then it's found the max values for each of those cases on every column. Great. So we can use group by with index hierarchy levels. So let's create a hierarchical column index. So we'll say higher COL equals PD multi-index, and then we can call the method from arrays. So this will allow us to build a multi-column, or issue multi-lists, excuse me. So let's say we want some cities initials, since we've been doing that a lot. NY, make NY again, and then let's just have the last two be SF or San Francisco. And then we're going to pass a list of lists, so let's add another list in there. This one will just be numbers. We'll say 1, 2, 3, 1, 2. Alright, so that's our list of 2 lists. And then for this, we'll name each index. So the names of the index, we pass the argument names, and we'll say it was the city, and then the second one we'll just give it a generic name, sub value, since it's just some numbers, 1, 2, 3, 1, 2. So let's make that. Alright, now let's create a data frame from that hierarchical index. We'll say data frame underscore HR for hierarchy is a data frame. We'll pass, let's say, a 5 by 5 matrix, so I'll create arranged. I'm going to reshape this to be 5 and 5, and then I'll set my columns equal to that index hierarchy. Cool. And now what I'm going to do, I'm going to say dframe underscore HR is equal to dframe underscore HR times 100. So that what that's going to do, it's going to multiply every object in that data frame by 100. And I do that for clarity reasons later on. just so it's really obvious that you have a 0, 100, 200, 300, 400, all the way to 24. So now we have a hierarchy index. Top index is cities, NY and SF. That sub-index is 1, 2, 3, 1, 2. And then we have our index on the side. So we have the column index and the regular index. So that's how you can use group by. We have those data frames, and you could use group by on them as well. So you could use multi-index from arrays to build a hierarchical index for your data frame. That's about it for this. You can check out the documentation on group by if you want to know some more details on it. We'll continue using it throughout the course, so if you don't feel 100% on it, you'll still have way more chances to see it again. Alright, up next we're going to learn about data aggregation. I'll see you there. Hey guys, welcome to lecture 44. This lecture is going to be on data aggregation. I'm super excited for this lecture because after the previous 43 lectures, we're finally going to be able to look at some real data sets and do a lot of analysis on them. So let's go ahead and get started. You're going to import NumPy as NP, Pandas as PD, and from Pandas import series and data frame. We do that for most of the IPython notebooks we start, so we're definitely going to do it now. So data aggregation consists of operations that result in a scalar. For instance, the mean, the sum, the count, those operations that we've done in the past. So let's go ahead and get some data to play with. So here's the URL we're going to use. We're going to look up the archives of UC Irvine machine learning class. So this is the link. When you click this link, or you can copy it from the IPython notebook viewer, you'll come to this page, and it's the machine learning database wine quality. And we're going to go ahead and mess around with the red, so the wine quality red CSV file. Alright, cool. Once you've downloaded it, go ahead and save it where you're saving your notebooks. And if we open up that file real quick, I'll open up in Notepad. Notice that it's separated by semicolons, not commas. So we're going to use read CSV like we learned in the past to set up a data frame, but we're going to have to set the delimiter as a semicolon, not just a comma. So let's go ahead and do that. We got dframe wine, that's what we'll call our data frame. And then we're going to use pandas, so pd.readCSV. And then go ahead and input the name of the file. So this one is wine quality.csv. Actually, it's wine quality underscore red, the way I called it. You can just call it whatever you want. And then remember the delimiter or the separator was a semicolon. Okay, so now we have our data frame. Let's go ahead and get a preview. Let's just see the first 5 rows. And we can do that again like we've done in the past by calling just the head of the data frame. Alright, so what do we got here? We got our index 0, 1, 2, 3, 4, etc. Pandas has done that automatically for us. We have different acidity values, residual sugar levels, the chlorides, the dioxides, the density of that wine, the pH level of that wine. And then the interesting ones we're going to play with for this lecture is the alcohol content of that wine. So for instance, this wine was 9.4% alcohol, and then the quality rating for that wine. So they rated it on quality. Okay, cool. So how about we find out the average alcohol content for the wine? How can we do that? Well, just like we've done in previous lessons, we're going to say dframe wine. We'll choose the alcohol column. And since we wanted the average alcohol content, we're just going to get the mean. So this is a data aggregation, since it's going to produce a scalar. So the average alcohol content for all these wines was 10.4%. Alright, great. So what else can we do? We can, if we want, just take a quick peek at what the entire data frame looks like. So the entire data frame is a whole lot of wine. It's 1,599 rows. So we got tons of information here to play with. We know that the average alcohol content in the wine was 10.4%. What else can we do? So that's an example of data aggregation. Can we make our own data aggregation? So there's built-in methods such as mean, but can we make our own? And yes, we can. So what we can do is create a function. We'll use def to create that function. And we're going to create a function called max to min. So max to min, we'll have it accept just ARRR as its input. And then we're going to return the max value of that array and then subtract the minimum value of that array. So we're going to basically serve this as a peak-to-peak function. So it's going to find the max and subtract the minimum. So now we have our function max to min. So using that, let's go ahead and keep that in the back of our minds. We've learned a lot about group by, so let's go ahead and implement that on our data set. So let's make a data frame called wino, or a group by object called wino, sorry. And we'll take our data frame, the frame wine, and we will group by, and we're going to group it by quality. So this was the quality rating of that wine. So we've done that, and let's go ahead and see the statistics on that. So we'll use describe like we've done in the past. Alright, so now we've grouped all the wines by their quality rating. So the quality goes from 3 all the way to 8. And we have stats on all the wines. So we have their alcohol content, their densities, their acidities, sugar, etc., etc. And we have their counts, the mean values, the standard deviations. Alright, awesome. So we're going to be messing around with that later. We can now apply our own aggregate function. So this function takes the max value of the column and subtracts the minimum value of the column. So let's go ahead and take that group by object we just made, wino. And the way we pass a general aggregation method is .agg. And then you're going to pass your function, max underscore to min, that we just made. Let's go ahead and run that. Okay, so now what this has done is it's gone through wino, that group we just made, that was sorted by quality, and it took the max of each column value and subtracted the minimum. Okay, so that's what we got as the result. And we can also pass string methods through aggregate. So to show you what I mean by that, we call the method wino.agg, and we can actually pass mean as a string instead of .mean method. We could actually just do a more generic mean. It's going to give you the same result, but it's just good to know that you can do it that way as well. So there you have, for instance, the average alcohol percentage for each wine. Alright, awesome. So let's go back to the original data frame, the frame wine. Just see the head of it, the first 5 rows. Okay. Nice. Now let's add a quality to alcohol content ratio. So what I'm interested in, I want to see if that quality rating has a link to the alcohol percentage of the wine. So I'm going to do that by adding a new column to this data frame. I'm going to say dframe underscore wine, and then I'm going to name this column, I'll say qual divided by alc space ratio. So this is the quality to alcohol content ratio, and it will be equal to the quality column, so this column right here, quality, divided by dframe underscore wine, the alcohol content column, this column right here. Alright, so let's run that. so now we've created that new column. Let's go ahead and check out the head now. Okay, and there's our column now, the quality over alcohol ratio. Great. So we have a whole column. We got that going. So just to go over some other stuff we've learned in the past, let's go over pivot tables. So we could have used pivot tables instead of group by. So how would we do that? We would say dframe line dot, and instead of calling group by, we could have also have called pivot table, like we've done in the past. And in this case, we could have specified that the index be equal to the quality column. Whoops, let me spell that right. Quality column. Excellent. And now let's take a look at that, and you get the pretty much the exact same thing we got when we used the previous methods of group by. Great. So we're not quite yet at the data visualization section, but I'll give you a little preview taste of what that might look like. In order to show you the plots, I'm going to need to call matplotlib and inline. So that will allow us to see the plots inline in the notebook. And then what are we going to plot? How about we make a scatter plot? So we'll say dframe underscore wine, and I'm going to call a plot method on that data frame. So we've seen this once before, but we'll see it in much more detail in future lectures. So the kind of plot I want to make, let's just make a scatter plot just for the heck of it. And on my x, I will make quality values, and I'm going to plot those versus the y. I'll say the alcohol. Okay, let's go ahead and do that. Alright, so now I've made a scatter plot of alcohol versus quality, and it's plotted all the points, so all the wines based on their quality, rating, and their alcohol percentage content. So that's pretty interesting. So we can see that the data is probably better fit for a box plot of some sort. So we can get a more concise view and maybe add some standard deviation lines and get averages. So we're going to learn about box plots in the future. I'll leave it as a challenge to you if you want to figure out how to do box plots right now. But don't worry about it. We have a whole section on data visualization. This is just a little taste of it. Most important thing to learn from this lecture was data aggregation. So let's scroll back and make sure we got that. So remember, data aggregation is basically just functions or methods you call that allow you to have a scalar result afterwards, such as mean, count, sum, etc. You can just call these by saying .mean, .sum, .count, and you can also, the important part is, make your own aggregation. So we did that. We made a function called max to min, and you can pass aggregation functions on your data frame by using .agg. And then you can also pass string aggregation methods by just saying .agg and then the string name of that aggregation. Alright, so we got a little taste of what it is to work with field data sets, and I'll see you at the next lecture, lecture 45. Awesome. Hey guys, welcome to lecture 45. This is going to be on using splitting, applying, and combining, so otherwise known as split, apply, combine. So we'll do the usual imports. I'm just copying and pasting these from the IPython notebook viewer link that I have for you guys. Alright, so what is split, apply, combine? The best way to look at this is just through a visual demonstration. So for instance, you can have a data frame or just a data set, split it up by a certain index. So in this example, it's split up by that letter in column on the X column, so A's, B's, and C's. You can apply something to it to get a new value, and then you can combine it back again. So in this instance, looks like the Y column was averaged out, and so you get the average of everything, and you can use this, do this by group by methods or other ways using pandas. this is the general principle of split, apply, combine, and we're going to learn about it a little more. So let's go ahead and get some data to work with. So let's go ahead and use the same data frame we used in the last lecture, the wine data frame, and we'll open this up by using pd read underscore CSV and saying wine quality underscore red dot CSV. And remember, the delimiter slash separator was a semicolon in this case. And then to make sure we actually got it correct, we'll just check out the first 5 rows. Alright, great. Okay, so in the last lecture we kind of explored alcohol content versus quality. So what if we wanted to know the highest alcohol content wine for each quality range? We can use group by mechanics to do a split, apply, combine procedure. So first what I'm going to do is I'm going to create a function that assigns a rank to each wine based on alcohol content, with 1 being the highest alcohol content. So what I'm going to do is I'll make a function. I'll call it ranker. It's going to take a data frame, and then from that data frame it will set alc content rank. And let's go ahead and make this one term, so I'll put underscores here. So it's going to create that column and set it equal to arrange a group of numbers by the length of the data frame plus 1. And then it's going to return that data frame. Okay. So we'll be using this function later on. Then let's go take a step back and look at the dframe underscore wine. So let's sort the data frame by alcohol in ascending order. So I'm going to say dframe underscore wine dot sort. I'm going to sort it by alcohol. Say ascending, pass that argument, put it to false, and then in place equal to true, so it affects our data frame. Okay, so now we have a data frame sorted. Now we're going to group by quality and apply our ranking function. So this is how we're going to do this. This is going to be the split, apply, combine technique. So I take my data frame wine, and I'm going to set it equal to dframe wine group it by quality, and this is where the apply comes in. I'm going to pass the method apply, and I'm going to apply that ranker function that we just created. So again, this ranker function assigns a rank to each wine based on alcohol content, with 1 being the highest alcohol content. So I'm applying that ranking function to the data frame as it's been grouped by quality. Okay, so take a moment, think about what the ranker function is actually doing, why it's arranging by the length, and why it's adding that 1. And then once you understand it, go ahead and preview what your data frame is going to look like. So let's go ahead and check the head of that data frame. Okay, so what do we got for our data frame now? We can see that the index of the rows has been jumbled up a bit, but if we come over here and look at the alc content rank, it looks like your data frame's been sorted by the highest alcohol content. So this is #1 alcohol content for the quality of 5. This is the #1 alcohol content for the quality of 8. And you can see these are pretty high alcohol content wines, 14.9%, 14%. So we can now get closer to finding the highest alcohol content for each ranking. So how do we finish this up? We can just call for the data frame where the alcohol content rank this last row right here equals 1. So we can say set an object called num of qual equals dframe underscore wine quality value counts. And then let's go ahead and see what that looks like. Okay, so what is this? This is just the number of wines in each quality count. So at quality 5, at quality 6, 7, 4, 8, and 3. And this is, so there's 681 wines that have a quality rating of 5, 638 wines have a quality rating of 6, etc., etc. So let's go ahead and show the combined information for the wines that had the highest alcohol content for their respective rank. Alright, so this is how we're going to do that. We'll take our data frame and then say dframe wine, call that last column we made using our ranker, content underscore rank, and say equal to 1. So dframe wine where your alc content rank was equal to 1. So when it's equal to 1, that means it had the highest alcohol content of any wine in its quality class, if you will. And then we'll just get the head of that. And how many dframes do we want to see? Well, we just want to see, or I'm sorry, how many rows do we want to see? We just want to see the same number of rows as there are quality batches. So we'll say num of qual. And looks like I forgot an E. Okay, let's run it again. Alright, there we go. So if you look at the alc content rank, they're all equal to 1. So there were 6 quality rankings in total, 3, 4, 5, 6, 7, 8. And these are the row indexes of the wines that had the highest quality, or the highest alcohol content for their quality class. So you can see these all have pretty high alcohol contents. They're all the highest in the class, and you can see how they relate to quality. So something we might want to ask ourselves is, are there any trends between the ranking of the wine and the alcohol content? You might start to wonder, is there a ranking between a higher quality ranking and a higher alcohol percentage? That might be an interesting thing to investigate. So the important thing about splitting, applying, combining is that we were able to get from a data frame, pass, and apply a function to it. So you're able to use group by to do the splitting and combining, and you're able to use .apply to apply functions to your data frame. Alright, so that's it for that. We'll go in lecture 46, we're going to learn about cross tabulation. Okay. Hey, welcome to lecture 46. And this lecture will be on cross tabulation. So for this lecture, we're just going to need to import pandas as PD. So this is going to be a quick lesson on cross tabulations. They're basically just a special case of pivot tables. So let's create a quick data set. And since this is going to be such a quick lesson, I'll show you a little trick in addition to the lesson. So I'm going to, from string IO, I'm going to import string IO, and that will allow me to create some data like this. So I'm going to make some comment lines, do a new line, set. I'm setting right now the column names as one line. And then for my sample animal intelligence columns, I'm going to have sample number 1. The animal will be dog, its intelligence will be smart. I'll have sample 2, it's going to also be a dog, it's also going to be smart. Sample 3, I'm going to have a cat, it's going to be dumb. Sample 4, I'm going to have a cat, it's also going to be dumb. And then sample 5, let's make it a dog. I guess we'll have one dog be dumb. Sample 6, we're going to make it a cat, and we'll have one smart cat. And then I'm going to end this just by seeing that comment chunk. Okay, so this is just a little trick for using string IO to read data. So this data is basically just a big comment, and then I can store it as a dframe by saying pd.read_table, and this is where we're going to use string IO. It will analyze that data, and then the separator is just going to be equal to \s plus. So don't worry about this. You can explore string IO documentation in Python if you wish. This is just kind of a little trick for creating data sets. We won't be creating any more data frames this way. It's just that cross-tabulation lecture is going to be pretty short, so I figured I'd add a little trick there for you. Okay, and our data frame worked out well. We got our sample numbers, the animal type, dog or cat, and its intelligence. It's either smart or it's dumb. Okay, so now we can create a cross-tabulation table, and it's basically just a frequency table. So if we call PD crosstab, that's how you can create a cross-tabulation table. And we're going to create it using the animal column, the intelligence column as arguments, and I'll set margins equal to true. So what is this going to do? Well, nothing apparently, unless I spelled something wrong. Margin, should be margins, excuse me. There we go. Okay, so what does this do? It creates basically a pivot table that is almost like a frequency counter. So it's counted the total number of cats, it's created this all column, it's counted the total number of dogs, and then the total number of all the items. And then it's separated out by the second input argument, which was intelligence. So it's grabbed all the animals as your first input, it's separated them out by intelligence, and then it's counted their frequencies. So you have 2 dumb cats, 1 smart cat, all of them are 3. You have 1 dumb dog, 2 smart dogs, all of them put together are 3. And then for all the animals, you have 3 and 3, and all of them together is 6. You could have also done this using a pivot table, but crosstab is just a little shortcut for the special case. Okay, and that's really it about cross-tabulations. We won't use them anymore throughout this course, but it's important that you know about them in case you find yourself needing to use them. Okay, and that's it. The next lecture is lecture 47, and we'll be learning how to install Seaborn. I'll see you there.